Hello everyone, this is Manish from Skillable India, and in today's session of geometric dimensioning and tolerancing, we are going to discuss very important key terminology which is about the controlled radius. Okay, where we use controlled radius and why it is important to learn about controlled radius. With the help of definition, we will understand this. The controlled radius is a variation of radius. Okay, so basically, we are talking about the control radius, which is a variation of radius. Its dimension, the size of a circular feature using the radius length. Okay, so here we are talking about the fillets or the round which we provide into the design. Okay, but it also gives an additional requirement that the surface of the contour must be a fair curve. Okay, so uh, whatever round or fillet we are providing, it must be have proper curve. Okay, what we have sometimes that we do not get the proper radius when we provide the radius to avoid the cis concentration. Okay, so this means that the surface must be continuous without reversals. Okay, so just showing with the help of one example we will discuss. So whenever we have a part like this, okay, if I draw one part, let's say first of all, in the first example, we are discussing with the first part. Okay, and we have provided a fillet radius at this center at this part. Okay, so let's say if we have given over here R10 plus minus 0.1. Okay, so if I have provided the dimension, which is the radius 10 plus minus 0.1, which is the 0.1 is the tolerance over here. Okay, so what can happen that this by to avoid, okay, what we usually avoid with the while giving the fillet radius to the part, whenever we have a sharp edges, okay, so there will be a cis concentration. So at the sharp edges, whenever there is a edges like this, okay, so always there is a cis concentration. To avoid this cis concentration, we usually provide the fillet, okay, to eliminate this cis concentration. Okay, but while applying this fillet radius, okay, so for this, after, let's say after manufacturing, it should lie within the boundary. Okay, it can be like this, and like, oh, sorry, if I will make, okay, so here you can see that it can be 10.1 or 10.1, or it can be 9.9. Okay, so in between this, it can be anywhere in between this radius. Okay, but sometimes what we actually face this problem, that after manufacturing the part, after manufacturing this radius, what we get, what we get is the uh, this type of part. Okay, in which you can see there are multiple reversals are there. Okay, there is not a, there is a zigzag shape into the part. It is within the tolerance zone, but it is having zigzag shape. Okay, so to avoid this, you can see this zigzag shape is also having the sharp points. Okay, so these sharp points also contains the cis concentration. So we are giving the fillet radius to avoid the cis concentration. Okay, so what we do over here is, now the main intention of giving fillet radius is to remove the cis concentration. Okay, but which is not taken care in this case. Okay, so in this case you can easily understand this thing is not taken care. So here again we have some sharp edges. Okay, because of which we are not fully able to eliminate the cis concentration. So whenever the application called for very smooth surface, okay, so whenever there is a smooth surface requirement, what we do is, we can add C in front of the R. Okay, so we provide the C in front of the R. So this shows the controlled radius. Okay, so this, whenever we are writing over C in the engineering drawing before R, so it means we are saying to the manufacturer that you have to control this radius. Okay, surface must also lie within the tolerance zone within the boundary of the 10.1 and 9.9. Okay, but the flats and reversals are not allowed. Okay, so these flats and reversals are not allowed. Okay, with the smooth surface within the boundary by which we are able to remove the cis concentration. Okay, in the second example, when we apply the controlled radius, whenever we apply the controlled radius to a part, okay, so to avoid the cis concentration, the symbol CR. Okay, so in front of R, 50 plus minus 0.5, we write it down this C over here, which is showing the controlled radius and is placed before the size dimension. Okay, so this C is placed before the size dimension. Now, the difference between the radius and the control radius is in the contours of the machine feature. So this is the, you can see in this example, that there are a lot of contours are there, like this contours are there. Okay, you can see this contours, although they are within the tolerance zone, within the plus minus 0.5, but still while the point along the radius dimension surface must only fall within the tolerance zone. Okay, points along a controlled radius, when we provide not R, we provide C over here. So the surface must fall within the tolerance zone and a continuous arc. Okay, so it will lie between this part. Okay, so it will lie within the boundary of the tolerance zone, within the boundary, and it will have a smooth continuous arc. Continuous arc. Okay, so this is very, very important. So whenever we require a smooth continuous arc, we provide C for the controlled radius before the size dimension. Controlled radius. Okay, so this is all about the controlled radius in the geometric dimensioning and tolerancing. For engineering drawings, this is very important to control the radius and have a smooth continuous arc and remove the cis concentration. Thank you all of you. In the next discussion, we will have some different topic. Thank you very much.